Okay, for today, we're going to discuss our lesson, which is lesson 1-3, finding the domain of a function. As we said before, domain is the set of all x values that makes the function defined. Okay, so in finding for the domain, it depends on the given function. So let's say, for example, for letter A, if the given function is a polynomial function, you don't need to do anything because the domain of a polynomial function is always the set of real numbers. It is the set of all real numbers. Let's say, for example, I have here fx is equal to 3x minus 5. This one is a polynomial function, and so the domain is the set of all real numbers, or in interval notation, you can write it as from negative infinity up to positive infinity. Same thing with example number 2. You have f of x is equal to x squared plus 2x minus 1. Again, this one is a polynomial function. Okay, and so the domain is the set of all real numbers or all numbers from negative infinity to positive infinity. Okay, so I repeat, if the given is a polynomial function, you don't need to do anything because the domain is the set of all real numbers. Okay, what about if the given is a radical function? Okay, it depends. It says here, if the index is even, the radicand cannot be negative. The radicand cannot be negative. Now look at this term, index. What is this index? Okay, index, okay, is the number written here. Okay, if there is no written number, it's understood to be 2. So the index is 2. Sometimes we have this cube root of x. So the index is 3. So it says here, if the index is even, like 2, 4, 6, and so on, the radicand cannot be negative. Radicand is the number or variable inside the radical sign. Okay, this is your radicand, that is your radicand. They cannot be negative. So set the radicand to be greater than 0. Okay, but the radicand can be 0 also. It cannot be negative, can be 0 and positive. So in general, you set the radicand to be greater than or equal to 0. So that when you solve for the domain of the square root of x minus 4, the radicand here is x minus 4, set that to be greater than or equal to 0, and then solve for x. So this is plus 4 plus 4. So now I have x is greater than or equal to positive 4. Okay? These are the possible values of x. It cannot be less than 4. Otherwise, this becomes negative. Okay, take note that the radicand cannot be negative. Now, here, you have here 3x minus 6, set that to be greater than or equal to 0, plus 6 plus 6. So I have 3x is greater than or equal to 6. So x is greater than or equal to 2. That is the domain. Now, the next one is the radicand is x squared minus 16 is greater than or equal to 0. So now I have x squared is greater than or equal to positive 16. If I am going to get the square root of both sides, this one is x is greater than or equal to positive or negative. Square root of 16 is 4. So there are two possible values of x. Now, how do you write the domain here? Okay, so the positive value That is, x is greater than or equal to positive 4. And the negative value is x is less than or equal to negative 4. Okay, greater than or equal to for the positive value and less than or equal to for the negative 4. We will have another topic on this when we will discuss inequalities, cases in solving quadratic inequalities. Okay, so let's try to plug in these values and find out if it works. So if it is greater than or equal to 4, 4 raised to 2 is 16 minus 16 is 0. Okay, it can be 0 but cannot be negative. Let's say 5. 5 raised to 2 is 25 minus 16 is a positive number. So there is a square root of a positive number. So greater than or equal to 4 are possible values of x. What about less than or equal to negative 4? Negative 4 raised to 2 is 16, minus 16 is 0, okay. Negative 5 is less than negative 4. Negative 5 raised to 2 is positive 25, minus 16 is still a positive number, okay. If I am going to draw this in a number line, graph this in a number line, this one is negative 4 and this one is positive 4. So less than or equal to negative 4 and greater than or equal to positive 4. These are the possible values of x's. In interval notation, I can write this one as from negative infinity to negative 4, union 4 to positive infinity. Now, what happens with these numbers here? Let's say negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3. These x values are not possible values of x. Let's say 3. 3 raised to 2 is 9. 9 minus 16 is a negative number. It cannot be negative. Okay? So, take note of that. If it is an inequality, positive, negative 4 are two values of x. Take the positive values to be greater than and the negative value to be less than. Okay? That is how you will solve for the domain if the given function is a radical function. What about if it is a rational function? Means say it's a fraction. So there are two cases. Fraction only, there is no radical. So let's say, for example, 1 over x plus 5. In a fraction cannot have a 0 denominator. So this part here cannot be 0. So that is x plus 5 cannot be equal to 0. Okay, that's the restriction. And then solve for x minus 5 minus 5. So x is not equal to negative 5. The domain are all values of x except negative 5. I can write this one as set of all x such that x is not equal to negative 5. Or you can just write there all real numbers except negative 5. Okay, that is if it is a fraction. Now, let's have some more problems. Let's say, for example, you have here 2x minus 3 over 3x plus 5. So again, the denominator 3x plus 5 cannot be equal to 0. So set that one, 3x plus 5 not equal to 0. So minus 5 minus 5. So I have here 3x is not equal to negative 5. Divide both sides by 2. X is not equal to negative 5 over 3. That is the domain. Okay. Now here in number 3, The denominator is x squared minus 25. So this one is x squared minus 25 cannot be equal to 0. So that is x squared cannot be equal to positive 25. Get the square root of both sides. So I have x is not equal to positive or negative 5. Now this is the final answer. It cannot be positive 5 or negative 5. Okay? Don't be confused with this one because this one is inequality. Where is that? This one, inequality. That's why we take the positive value to be greater than, the negative value to be less than. This one is not an inequality. I mean, not using greater than or less than, greater than or equal to, less than or equal to. So x is just not equal to 5 and not equal to negative 5. Okay? For number 4, the denominator is a trinomial. So set that one to be not equal to 0. And then solve for x. So we can solve this by factoring the given trinomial. Okay? Using the zero product property. This one, square root of x squared is x, because x times x is x squared. These are both plus. Okay, so the factors are both plus also. Okay, what are the factors of 15, which when multiplied is equal to 15? Two numbers which when multiplied is equal to 15, but when added is 8, I should say. So that one is 3 and 5. Okay, 3 times 5 is 15. 3 plus 5 is equal to 8. Okay, this is plus 15. So now by the zero product property, I can have this one, x plus 3 is not equal to 0, or the other one is x plus 5 is not equal to 0. So this one is x cannot be equal to a negative 3, and this one, x cannot be equal to negative. Okay? For number 5, the denominator is x squared plus 4. So x squared plus 4 is not equal to 0. So x squared is not equal to negative 4. There is no number which is squared is equal to negative 4. Okay, so here, this one is all real numbers. There is no restrictions. Okay, there is no restriction because I will write this one, no restriction. It means it can be any real number, even if it is negative. So a negative raised to 2 is positive. So there's no problem with that. If it is 0, 0 raised to 2 is 0 plus 4, it is still 4. Okay, so there is no restriction to this once you have this one. Okay, because there is no square root of a negative number. Okay. Now the next type of fraction is a fraction wherein the denominator is a radical. If the denominator is a radical, you set the radicand to be equal to not equal to 0, okay, because it's a fraction. Not equal to 0, but it has to be greater than 0, okay? So you set the radicand to be greater than or equal to 0, okay? No, it cannot be 0, so it's just greater than. So Going back to the first page a while ago, if it is just a radicand, it's not a fraction, okay, greater than or equal to 0. But if the radical is appearing in the denominator, you set that one to be just greater than 0. So minus 3 minus 3. So x is greater than negative 3. Okay? It cannot be negative 3 because negative 3 plus 3 is 0. And the denominator cannot be 0. It has to be greater than negative 3. Okay? So you can write this one as set of all x such that x is greater than negative 3. Again, this one is a radical, okay? And it appears as a fraction. So it is x plus 2 is greater than 0. So minus 2 minus 2. So x is greater than negative 2. Or set of all x such that x is greater than negative 2. Okay, this one, the last one, is the denominator is square root of x squared minus 100. Okay, so this one is x squared minus 100 greater than 0. So x squared is greater than positive 100. If we're going to take the square root of x squared and the square root of 100, this one is x is greater than positive or negative 10. Now, this one is inequality. So what we do is, for the positive value that is greater than, for the negative value that is less than. Okay? So there you go. So if you're going to draw a line graph for this, this one is negative 10, this one is positive 10. Strict inequality. So open circle going to the right, this one is going to the left. So this one is negative infinity up to negative 10, union 10 up to positive infinity. Meaning to say these numbers here are not included. Let's check. Greater than 10. So 11. 11 raised to 2 is 121. Minus 100 is 21. So that's not 0, and it's positive. Negative 11, the same thing. Okay, it's not 0, and it is positive. Okay, what about if the number is in between? Okay, we said a while ago, these numbers are not included. It's, let's say 0. 0 raised to the 0 minus 100 is negative. It cannot be negative because that is a square root. And it cannot be 0 because it is a fraction. Okay? That is how you will identify the domain of a function. So it depends. As a review, if it is a polynomial function, the domain is just 0. If it is radical, set the radicand to be greater than or equal to 0. If it is a fraction, okay, set the denominator to be not equal to 0. If it is a fraction with a radical denominator, okay, this one cannot be equal to 0, but it has to be greater than. So set the radicand to be greater than 0. Okay, so you can now do your classwork. It's on Google Classroom. Thank you.